This is IAT806 Lecture 4, and today's topic we are going to talk about two things. The first is an example of some computer graphics where we're going to draw a rocket, and that will lead to the discussion of the Java class and the representational ideas that we're going to need throughout the rest of the term for the technical stuff that we're covering in IAT806. So the first part is the rocket. So let's think of an example of what we would like to do is to draw a little rocket for the purposes of eventually building a game like the historic Asteroids computer game, where a rocket flies around in virtual space and you shoot bullets at asteroids and blow them up. So first let's draw a rocket. And as you can see, using this piece of straight line code, it's very simple. We simply clear the background and draw a triangle, set the fill color to be white on a black background, and draw a triangle and two little rectangles. So let's just show the processing window, and there's the code once again. I've copied and pasted it in the background. So let's press play and see what it looks like. And there you can see a tiny little rocket, which is the triangle, and the two tiny little rectangles underneath it. And as you can see, we have just drawn that, and that's the only thing that this program does, is draw that little rocket. Now, if you're going to build a video game, you need to be able to draw that rocket moving around in space and shooting things, and you need to also draw the asteroids, but we're going to concentrate on drawing the rocket today. So if you want to draw several rockets in different locations on the screen, there's one way you could do it, and it's not terribly effective, but I'll mention it just to dispense with the idea, is you could copy and paste the code. And if you just copy and paste the code, as I'm just about to do right here on the processing window, copy the code we need. Don't copy the background because we don't want to clear the screen a second time. And, we could stop, press play, and then we'll see one rocket drawn on top of the other. You can't tell, but trust me, they're both in the same place. Let's instead add an additional translate. And by 20 and 30 in Y, 20 in X and 30 in Y, press play, and now we see two rockets. Great. So we got two rockets. If we really wanted to move them around, however, what we want to be able to do is to translate and perhaps rotate those things independently. Alternatively, or in addition really, one of the things we could do is to create a method to draw those things. So what's a method? We've seen a bunch of methods before. A method is a piece of Java code that has a name, takes parameters, maybe no parameters, returns a value, possibly void and therefore returning nothing, and executes some statements. That's the real reason why you create a method, is inside the method is a procedure, a sequence of steps that you'd like to be done, perhaps a loop, maybe a bunch of loops. It does that, and every time you call a method, that procedure gets executed. There are other names for methods. One name is procedure, and the implication there is it just does things, and function, where it's the same as the procedure, but in addition, probably what it's doing is computing something and returning that computed value back to the piece of code that called it. So we've seen methods before in plenty of our code that we've seen so far. We've seen the fill method with red, green, and blue parameters, stroke with red, green, and blue parameters, translate in X and Y, rotate by theta, push matrix, pop matrix, point line, triangle, rect, ellipse, and presumably in your first assignment you've used many of these yourself. We've also defined methods before. Void setup with some body to be executed at the startup of a processing program, and void draw, which is called repeatedly and automatically by the processing system if you define it. So now let's define a method for drawing a rocket, and I've called it, surprisingly, drawRocket. And its type is void, which means it returns nothing. It just simply does its thing and returns without computing anything. So now let's just copy and paste that code into processing, and we'll see how that goes. But one proviso just before I do that: when you define a method, like setup, like draw, as soon as you define one method, all the code that you create has to be within a method, except for the declaration of variables. So once you start using methods, all code must be in a method. And part of the reason for that is it's based on what processing is expecting as to how it interprets the chunk of code that you've put inside the processing window. So you'll just have to accept at the moment that the way it works is when you define a method, everything else has to go along with it. So what we'll do is just go to the processing window again and do void drawRocket. Hopefully I spelled it right. I think I have an extra J in there. And a left brace or an opening brace and a close brace here. There we go. Now if we press play, nothing happens. You just get an empty screen. So what we're going to do, empty draw area, is also define setup. Set the background again. And then call drawRocket. And there it is. Press play. And once again, we get our rocket located right here. So nothing much has changed between the previous example and the one we're currently looking at, except that we've got an extra piece of code which is set up calling drawRocket. And part of the reason for that is as soon as you define one method, you need to define setup and draw so that you can have a well-known starting point for your program, which is setup. So creating that method doesn't really seem to help much. It certainly is capable of drawing a single rocket, and you could call it a bunch of times. But drawing a rocket at a fixed location is really the first step of the job. What we really need is arguments that allow me to tell the program where I want the rocket. And we must figure out the relationships between the position and the location of the rest of the parts. And argument variables to the method are available within the method, but not outside. And that's something called method scope, and we'll explain that a little bit more as we move forward. So also, I would like to specify rotation. Currently, I specify the nose position, and it draws the rocket that faces straight up. And that's just built into the way I've set the geometry for drawing the triangle of the main body of the rocket. To rotate the rocket, I could figure out a whole bunch of new positions or vertices, which is way too hard. So instead of rotating that rocket by recomputing its vertex locations, instead what I'm going to do is rotate the paper, as we talked about in previous lectures. And while I'm rotating the paper, I may also, might as well, while I'm at it, translate it so that I can move the rocket around in space. So to prepare for translating and rotating, I first want to draw the rocket centered about the origin 0, 0. And the reason why I want to do that is when I want to rotate the rocket, I want it to rotate around what looks like the middle of it. And so therefore, I need to set the geometric center to be in the center of that triangle that we've got. So to do that, here is drawRocket with some arguments. The method here has, once again, is void. The name is drawRocket, but instead of the previous one where it took no arguments, it now takes 3. Int x, int y, float rot for rotation. X and y are going to be the xy location of the rocket when I draw it, and rotation is the amount I'm rotating it from the vertical. The next 2 lines here are defining 2 what are called constants, and we know that they are constant because there's a new Java keyword that I'm using here called final. When you say final and then the type and then the name of the variable, what that means is that you can only assign that variable one value once. And what that means is as soon as you assign the value, typically in the same value where you declare it, what you're doing is saying that that value, half height in this case, will never change. And therefore what you were doing there is defining a constant. So we say final int half height, and final int half width. And then I'm going to do the triangle rect mode and 2 rects here, but instead of defining it as raw numbers as I did before, I'm going to use this half height and half width information to define the geometry of the rocket. So now what I'm going to do is copy and paste that into processing. So there it is. I've pasted it into processing, and once again, int x, int y are the location, and rot is the rotation. I'm not doing anything with that information at the moment. As I said in the slide that we just left, we're purposely ignoring the arguments for now. But if we stop it and restart it, we can see that first off, there's a little bug, and what happened is I didn't change the call to drawRocket. I needed to make sure that the parameters to drawRocket, the number of them and the type of them, is equal to the specification I set up here. So let's press play. And there it is once again. But now, because I've redefined it such that the middle of the rocket is at 0, 0, we just see the lower right corner of the rocket, the lower right quarter of it. Okay, let's go back to the slides. Now, because I said it would be a good idea for us to take the parameters and use them to set the location and the orientation of the rocket, what I'm going to do is put in two transformation calls, namely translate and rotate. And I've just simply highlighted that in the slides here. And so let me go back to the processing window, and I'll put that in here right after the two final calls here. So translate X and Y, and rotate rot. That's what I want to do. Very straightforward. So I'm going to stop it and restart it. And right now we get the same thing because we set the X location and the Y location to be 0 and the rotation to be 0. So let's, instead of just drawing one rocket, let's draw two. And what we're going to do is set this to be kind of the same values we had before, 20 and 30. We'll hit stop, hit start, and we see two rockets. This one up in the corner still, and the second one that's 20 to the right and 30 down. Now let's, in addition, go back to the screen and set this to be 40. Oop, that's 400 instead of 40, and 40. And I'd like you to think a little bit before I press play what that's going to do to the collection of rockets that we've got. We have two rockets. Just think about what's going to happen. Okay, we press play, and what we see is that indeed we have translated the rocket, the first rocket, by 40 over and 40 down, and so there's the first one. And then we further translated over by 20 and over by 30, down by 30, and we get this second one down here. It's even more evident what's going on when we set the rotation value. I'm going to set it to a small value so that we don't get things completely disappearing off the screen. And as you can see, the rotation of the first propagates along to the second. And the reason why this happens is because translate and rotate accumulate. That is to say, you do a translate and then you do a rotate that builds on top of the translate that we did. So the first call to drawRocket translated by 40 and 40 and rotated by 0.2, and then the second call to drawRocket translated by 20 to 30 in addition to the previous thing in the rotated coordinate system, rotated by 0.2. The rotate by 0 didn't do anything, and so what that means is that both of these rockets have been in fact translated by 40 and rotated by 0.2, with the second rocket translated additionally by 2030. So we don't really want that. You would like the rockets to be independent, and when you do something like call drawRocket, the general expectation is that any kind of drawing is done in isolation. And we've already covered how to do that in a previous lecture about how to isolate transformations done for one thing from transformations done from another, and that is to do popMatrix. So let's go back to the slides and see where that would end up. So the text in the slide basically says that what has happened is that when we call drawRocket twice, it doesn't seem to work right. What happens is the first call messes up subsequent calls. That is to say, the geometry, the effect of transformation, accumulation, building on top of each other, happens because that's the way it's built, and we need to have not yet taken any steps to prevent that. So what's happening is that when you move the paper, translate and rotate, the paper stays moved, and subsequent paper moves, subsequent transformations, or additional translates and rotates build on top of the previous ones. What we want is to move the paper, draw, and then return it back to its previous state. And of course, what that means is we need popMatrix and popMatrix. And here's just a recap of what that means. popMatrix remembers the previous paper position, and popMatrix restores the paper to the remembered position. And you could call those in pairs as often as you like. So there's the extra piece of code that we're going to just put in, popMatrix here and popMatrix at the bottom. If we go to the processing window, we'll see what we can do, and that is to put popMatrix here. And just before the end of the procedure, oopsie, put popMatrix there, press stop, press play, and what we get now is the first rocket drawn 40-40 and rotated by 0.2, that's this guy, and the second one at 20-30 not rotated. So you can see it's to the right less and down less than this one. Great. So now we've got a method that can draw a rocket independently of other rockets. And it doesn't matter also if we reorder these things. Let's just put drawRocket in a different order. And what will happen is we'll just get the same stuff, right? There's the first rocket, which is now drawn second, and the second rocket, which is now drawn first. I know that's a confusing way of putting it, but that's essentially what has happened. So now that we've used popMatrix and popMatrix, what we've done is we've isolated the drawing of this rocket from the drawing of every other rocket. And all calls to draw a rocket, every time you call it, you'll get a new rocket in a new position, and it won't affect the position or orientation of the others. So that's kind of a cool thing to do. But so we've figured out a method of drawing this object all by itself without it interfering with other drawings. And so now what we're going to do is talk about how to create what's called an object out of this drawing method. So that's it for the section 4.1 of lecture 4, which has been about computer graphics, Rocket,